Welcome to this lesson on linear, quadratic, and exponential graphs. Linear, quadratic, and exponential functions are shown below. Let's compare their characteristics to find similarities and differences. All right, so you have the parent functions graphed, and you have the parent function equation. So for linear, of course, it's x to the first power, and it's a straight line. For quadratic, it's x to the second power. And then it's a parabola, it's that U-shaped graph. And then for exponential, your x is actually the exponent, which is why that word exponent is in exponential. All right, so let's go over some characteristics. So first of all, the domain for each one of these is all real numbers. Remember, domain is the x values, and all three of these functions go forever in the negative direction and forever in the positive direction for your x values. So that's why their domain is all real numbers. And of course, you can write that in interval notation like this. That means the same thing. Okay, for range, for linear, we're looking at the y values, and for linear, range goes forever in the positive direction and forever in the negative direction, so it's also all real numbers. For quadratic, in this particular case, it's everything from 0 and above. So it's y is greater than or equal to 0. And it does touch at 0, so you do include 0. And if you wanted to write that in interval notation, it would be like this, and you use a bracket for 0 because it does touch at 0. And then for exponential, it's everything from 0 up. But one thing we have to remember about exponential is it has that asymptote. So it never actually touches, even though it looks like it does on this graph. If we zoomed in really far, it would never actually touch at 0. So it's y is greater than 0, but not equal to. Or you could write it like this. No brackets because it doesn't actually touch at 0. All right, and then some characteristics. So for linear, it's a straight line. It's going to have a constant rate of change or slope. And remember, it's always x to the first power. For quadratic, you have the U-shaped parabola. And remember, parabolas have axis of symmetry because parabolas are always symmetrical. For this particular one, the axis of symmetry would be here, the y-axis, or x equals 0. And then it's also going to have a vertex, or a maximum or min. For this case, of course, it would be a min because it's the bottom of the parabola. But if your parabola was like this, it would be a max. And then for exponential, the graph is J-shaped. For a growth, remember you have growth and decay. And for decay, it would be like this. So like a backwards J. And don't forget that exponentials have those asymptotes where the graph approaches it, but it never actually touches it. All right, let's keep going. So let's use the graph to answer the questions below. So we have A is a quadratic graph and B is an exponential. So number one, what type of function is modeled by graph A? That is a quadratic. It's got that U-shaped parabola. And then number two, what type of function is modeled by graph B? That would be exponential. This is actually an exponential decay, if you want to add that, because it's a backwards J. All right, which function has the higher maximum value? Well, if you look at the functions, they both go to infinity, positive infinity. So they both don't really have a max. And you can put, they both go to infinity. Which function has a lower minimum value? Okay, so these do have minimum values, and it looks like graph A goes below the x-axis. Graph B is never going to actually touch the x-axis because that's the asymptote, so it would be graph A. Do either of the functions have a constant rate of change? That would be no. Only linear has a constant rate of change. Remember, linear is always rising at the same amount, but both of these have that curved shape. That means there is no constant rate of change over the whole graph. All right, number 6, do either functions have an asymptote, and if so, where? Yes, graph B, that exponential function definitely has an asymptote, and let's look and see where it is. It looks like it's the x-axis or y equals 0. All right, number 7, how does the domain of each function compare? Well, quadratic and exponential functions both have domains of all real numbers, so they are the same, and they are all real numbers because the x values go forever in the negative direction and forever in the positive direction, from negative infinity to positive infinity. All right, and then how do the range of each function compare? So the range of graph A is from here and then up. And let's just estimate that. I'm going to say that's about, I don't know, 0.3. Negative 0.3 because it's below. So for graph A, its y is greater than or equal to negative 0.3. And it does touch at 0.3, so I'm going to put equal to. All right, let's scroll back up and see for graph B. So graph B is everything from here up, but remember it has that asymptote, so it doesn't actually touch at 0, but it is everything above 0. So we're going to write that as y is greater than 0, but not equal to. Okay, you can stop your video now and complete your practice.